हेलो स्टूडेंट्स, आई होप यू ऑल आर डूइंग गुड। आइए आज का टॉपिक शुरू करते हैं। टुडेज टॉपिक इज सोडियम बोरोहाइड्राइड। इट इज ऑल्सो अ वेरी इंपॉर्टेंट reagent just like lithium aluminum hydride which we discussed in our previous videos. So sodium borohydride contains positively charged Na plus ion and BH4 minus ion. See the structure of BH4 ions. BH4, it is tetrahedral and hybridization of boron is sp3, and this whole species is negatively charged. Now let's see how this sodium borohydride is prepared. Now you can see 4 moles of sodium hydride reacts with methyl borate, 1 mole of methyl borate at elevated temperature of 250 degrees Celsius to give sodium borohydride and 3 moles of sodium methoxide. You can see only one carbon is there, so this is sodium methoxide. Now students, let's see the important properties of sodium borohydride. Unlike lithium aluminum hydride, sodium borohydride is soluble in ethyl alcohol. ETOH means ethyl alcohol. Lithium aluminum hydride, it was insoluble, but sodium borohydride is soluble in ethyl alcohol and it is also soluble in isopropyl alcohol. So in most of the reactions, sodium borohydride is used along with ethyl alcohol or isopropyl alcohol as solvent. Now let's see the next point. It is insoluble in ether and THF. So these 2 points are different from lithium aluminum hydride. Sodium borohydride is insoluble in ether and tetrahydrofuran, that is THF. Next, third and fourth points are very important points. Just concentrate on it. It is a milder reducing agent. Milder means slightly weaker than lithium aluminum hydride. It is a milder reducing agent than La. Now let's see the reason why sodium borohydride is weaker and lithium aluminum hydride is stronger. Now you can see in lithium aluminum hydride, Al single bond H, that means aluminum hydride bond is present, and in sodium borohydride BH bond is present. Now we all know aluminium belongs to third period, its atomic number is 13, configuration 283. That means from third shell onward size of atom becomes bigger. So there is a bond between a bigger atom and a smaller atom. So due to the size difference, this bond becomes weaker. This bond becomes weaker. That means hydride ions are more available in lithium aluminum hydride than boron hydride. Here boron belongs to second period and its atomic number you all know, it is 5, configuration 2, 3. It has only 2 shells and hydrogen is also the smallest atom. So the bond between 2 small atoms is slightly stronger than ALH. So here hydride ions are not released that easily. Now see the fourth point. Again, fourth point is very important point. It is a selective reducing agent. Now you can say sodium borohydride is a selective reducing agent. Easily you can remember students, because you see in the name of sodium borohydride we have S. S stands for sodium, S for selective. So easily you can remember that it is highly selective reducing agent. It reduces only the carbonyl group of aldehyde and ketones. So once again, I am repeating here, just concentrate. It is a selective reducing agent. S for sodium, S for selective. It reduces carbonyl group of CHO and ketone. That means CHO is aldehyde and CO is ketone. But it cannot reduce epoxides. It cannot break this ring. Then esters, acids, its salts, nitriles, nitrates, cyclic esters of organic acids. What are cyclic esters of organic acids? Cyclic esters of organic acids are also called as lactones. Now what are lactones? I have taken only 2 examples. Alpha lactone, you can see it has a triangular structure. One oxygen atom is there and one carbonyl group is there. Actually it is an ester. Other example is beta lactone. Here also you can see ester group is present. So these functional groups cannot be reduced by sodium borohydride, whereas lithium aluminum hydride is able to reduce these groups, which we have already discussed in the previous video. Now let's see, students, some of the functional groups and the products that it forms. That means sodium borohydride can reduce these functional groups. This is the carbonyl group which is present in aldehyde and ketone. Carbonyl group is reduced to 2-degree alcohol CHOH. Actually, hydrogen atom gets attached one to carbon and the other one to oxygen, and we get 2-degree alcohols. Next is oil chloride. Here oil chloride, you can see Cl minus gets replaced and COCl gets reduced to 1-degree alcohol. CH2OH is 1-degree alcohol. Now here you see isoalkyl halides. Now halide group is present in the second carbon of the chain. This is isoalkyl halide. They are reduced to alkanes. CH2 group comes here. If you join the chain, you get an alkane. Next is, here you can see trialkyl halide group is present. Now this gets reduced to trialkyl methane. It contains one carbon atom. So we know methane has valency 4. 3 valencies are satisfied by R and 1 gets satisfied by H. Therefore, it is called trialkyl methane. Now see another a special compound here, tosyl hydrazone, and its formula is, you can see C double bond N. Of course, the valencies of carbon are satisfied by other group. C double bond N NHTS. This is tosyl hydrazone. It gets reduced to methylene group CH2. Now here you can see ozonide. From this structure itself, it's clear it is ozonide. So this ozonide gets reduced by sodium borohydride to 2-degree alcohols. It gets reduced to 2-degree alcohols because bond breaks from here. This oxygen goes with zinc to form zinc oxide. Here we get aldehyde. That aldehyde further gets reduced to 2-degree alcohol. Here also we get aldehyde that gets reduced to 2-degree alcohol. Now here you can see benzene diazonium tetrafluoroborate. This benzene diazonium tetrafluoroborate gets reduced by sodium borohydride into benzene. C6H6 is benzene. Now let's see another example. RN3. N3 single minus is azide group. AZIDE, azide group. So alkyl azide groups, they are reduced to 1-degree amines. RNH2 is 1-degree amine. Now see the last example. Here last functional group, C double bond N single bond. This is imine. Here you can see this this structure is called imine. Imine gets reduced to 2-degree amines. So amines are reduced to 2-degree amines. Students, now we'll see some of the examples which are reduced by sodium borohydride. Yeah. Now let's